Okay, you can start. Thank you.
Hi, I'm Elliot, and I'll be interviewing you today. This is an anonymous interview, so feel free to introduce yourself and tell me as much or as little as you would like about yourself.
Yeah. So, hi everyone. I am Abhishek, a pre-final year computer science student from India. I'm currently interning as a SD backend in a healthcare-based startup and actively interviewing for full-time roles.
Cool. Okay, I have a couple of questions I can't ask, but if you only get through one question, that's totally fine too. Because each one of these questions is hard enough that it could take up an entire interview. So don't feel the need to rush to get to the next one. But if you've seen one of them, you might get through it really fast, and that's completely fine.
Yeah, sure.
Okay, here we go. Come on, let me paste this. Okay, it's not. Does this thing support paste? Is there a way to this? I know with CoderPad I can just I can paste in here, but it doesn't look like this is going to let me paste. Does anybody have, I have not used Coder Interview or .io before, so I'm not. Okay, there we go. Well, let me see if I can comment this out. No, it doesn't look like it supports that. Okay. Anyways, you can start reading it while I turn it into a block comment.
All right, since the statement is pretty large, so I'll just jump to the input and output and see if I can understand anything from it. Okay, let me go through the problem statement itself. Given a list of accounts where the first element is a name and the rest of the elements are email representing emails of the account. So for John, it's johnsmith@mail.com. Then again, John_New York@mail.com. Now we would like to merge these accounts to two accounts definitely belong to the same person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to two different people, as people could have the same name. A person can have number of accounts initially, but all of they definitely have the same name. After merging the accounts, return the account in the following format. The first element of each account is the name, and the rest of the elements are email in sorted order. The account themselves can be returned in any order. So if we see the input, okay, so for John, there are two emails. Again, for John, there are two emails again. For Mary, one email, and for John, again, two emails.
Yeah, it's important to
So,
realize I think there's actually two different Johns in the example. So you've got John
yeah,
and John Smith and John New York. And then you've got a second John that's John Smith. And because these two Johns share John Smith, you know they're the
yeah,
same John. And that way, then you know John 00 and John New York belong to the same John because of John Smith. But then there's this I believe there's a John who's Johnny Bravo, and that's a different John.
yeah, yeah. So just to check, so we merge two, yeah, so we merge two set of emails only if, yeah, or we merge two set of names only when there is a common email between them. Otherwise, it will remain as it is.
Yes, there has to essentially be a common email between the two lists in order for them to belong under a single person.
All right. So, all right. So, in each of the individual list, we have the first element would be the name, and all other subsequent elements would be the email associated with it. So, yeah. So, what we can do here is we can. Okay, let's see. Since there is a there are three Johns, and in the answer we have two John which are different. So there has to be some way where yeah, there has to be some way where we are able to know that both the Johns are different.
Mm-hmm.
So, yeah, so the first approach which would come to my mind is I will assign all these individual characters or individual names as a number. So that number will be associated with the index itself. So what I mean is the first John would be assigned number 0. Then the second John would be assigned again number 1. Mary would be assigned number 2, and the fourth John would be assigned number 3. So uh, these are just the indexes associated with each of the accounts. Now what I can do is uh, yeah, so now I can make a hash map of uh, key as the individual email IDs, and the value would be the list of uh, the value would be the list of indexes of the characters it matches. So what I mean is, so for example, let's see which one was the common one. So John Smith was the common one. So if I take John Smith as the key here, yeah, so it will contain 0 and 1. Similarly, now if I take the second one, John New York at the mail would contain, since it is common to only one, I guess, that is the first John. So I will store 0 in my value, and this thing will keep increasing in size until I've iterated through each of the individual email IDs. So after I get all these email IDs, now it is pretty easy to decide which one are the common ones. So this is why if at any instant I see that one of the values have more than if the value in the dictionary, if any of the values in the dictionary size of the list is greater than 1, so this means that I can merge all those particular values into one single.
Wait a minute. You said you can merge them if the number of items in the list is greater than 1?
Yeah. So here.
What if there's 10 items? What if there's 10 different items in your list, right? Because this list has an arbitrary length. And you could have 3 different email addresses that are each in 3 of those items, but they have no overlap.
Okay. So if you see here for John Smith at gmail.com, we can see there are two. We have 2 names which correspond to John Smith at mail item. So
okay, but it doesn't have to be 2 items, right? There could be 100 items in one of these sublists. That's not a requirement. It just happens to be in the example that there's 2 items to keep the example simpler.
Yeah, so it can be 1, 2, 3, or no, it can be 7, 8, 9, or 10. So all these,
Mhm.
so John Smith@mail.com correspond, or it contain, yeah, it comes from all these particular indices. That is what I meant.
Okay, so here's a
So
question. What do you think
yeah,
the runtime of this solution would be? Worst case.
yeah, okay. So if okay, let's see. If I'm generating the individual dictionary itself, so for this I would be iterating through the account list. So this is why, mm,
Let's say you already
yeah.
even
So
just you have the dictionary.
yeah,
What's the worst case time complexity just to generate the output from the dictionary?
all right. So then, uh, yeah. So now, how do we decide which ones to merge? So that comes from the size of the value itself. So here we can see 0, 1, 7, 9, 10 all are the same person. So this is why these all indices will correspond to the single person. And now, if you see the given answer list, there we
Let's
have.
think of a specific case. Let's
Okay,
say
okay, okay.
that
Yeah,
we have n email addresses, and every single one of those email addresses is, so you have every single one of those email addresses is in each of our sublists. So the length of this array would be n, the length of this array would be n, the length of, you would have n more arrays of length n. That's a possible worst case scenario. What would how would the running time work out there?
yeah. So I think in that case, it would be somewhat quadratic order, since we would be again iterating through the entire dictionary, and then using the values in the dictionary, we will be we would be making either a list or again a dictionary, and then we would convert that dictionary into a list of lists so as to get our desired answer. And
Yeah, I mean, so
yeah,
what you would have to do, right, at least the way you've got it set up, is you've got this one index, right? And then if you're going to
yeah,
choose to merge it, you're going to have to search through all of Johnny New York to see if that 0 is matched with this 0. And you're going to, so
yeah, yeah,
that search will take n time, and then you're going to
yeah,
have to
yeah,
do that for n items in here. So just for doing these 2 items, it would be n squared. And then you've got to repeat that entire process n times because you've got n items in your list, so it would be actually be n cubed. So can you think of an approach to this problem that would run in linear time? And it can be helpful to think about different data structures that you might use, because these problems are designed to be solved with particular data structures that allow them, more efficient solutions.
yeah. All right. Yes. So I think I missed one of the ends, so it will be cubic. So how do we further optimize this solution, since it is taking too much of time? So uh,
Well, I don't know that I would suggest optimizing this solution. I think there's probably a different approach you could take that would be more efficient. Like what kind of data structures can you think to use here that would be, maybe helpful?
yeah. So I can think of uh, yeah. First, I thought of the hash maps, but again, it will take too much of time. So instead of going for hash maps, uh, I think we can go for graphs here. And okay, so using graphs, then how do we decide? Uh,
Okay, so if you're going to use a graph, first of
yeah,
all, what is
since
the graph going to look like?
yeah, sure. So if we go with the graph where we would be having nodes and edges, so uh, the nodes, I think the nodes would be the individual names, and then the uh, Yeah, the nodes would be the individual name and the email IDs, and then uh, yeah, we will be having edges only if uh, it is a part of a single list. Otherwise, we won't be having any edges between the nodes. So what I meant is, so with John and John Smith at the rate mail.com, there would be a edge. Yeah, but how do I decide which ones to take for my answer then? Uh,
Okay, so you're saying that you would have email addresses connected to other email addresses. Yeah, is that what you're saying?
yeah, yeah. So there would be a directional edge between both the emails. And
Okay, let's say we had such a graph that connected up every single, well, first of all, how would you build that graph from the input? Like as you went through the input, how would you decide what connections to make?
yeah, so if we take the first one, here we will see that since these two email IDs are a part of a single uh, are a part of a single list. So this means that both of them correspond to John. So what we can do is we can make a edge between both of these uh, email IDs. But again, storing these individual email IDs and assigning a edge and then going for any
So what entities, what are the nodes and what are the, so you're saying is there going to be an edge between John Smith and John New York or between John Smith
yeah.
and John? Like what were you saying there? That wasn't clear to me.
Okay, yeah, sure. So okay, so we can have an edge between these two email IDs. So for each of the names, we would be having edges between all the email IDs between them.
Okay, let's say we have a graph where all the email IDs are connected and
Yeah.
or what you've established the connections that should exist. How are you going to produce the output using that graph?
Yeah, so now so now I think we just need to find each of the individual connected components in the graph. And since since these two would be common by some of the nodes, so this is why even this node would be visited, and we will see that after we visit first John, and when we come at the second John, we'll see that all the nodes of this particular John are already visited. So
wait a minute,
this is why
we wouldn't have visited John 00. That's not in the first one.
Yeah, it actually does not matter since we are having a bidirectional edge. Okay, so let's see. And
remember, we're not working with this input structure anymore. We've got a graph, right? So
yeah.
The graph has nodes.
Yes.
Those nodes, where do you decide where to start, for example? Which node do you start from?
Yeah, okay, let's take this particular example itself. And again, going with this particular string inputs won't be good, I guess, since
what's wrong with strings?
I guess using the same particular strings again and again would increase the overall runtime complexity. So we can assign numbers to each of the strings.
Why would using strings increase the runtime complexity?
All right. So if you compare one and a particular string, so yeah, so let's say this one corresponds to a node in the graph, and this string also corresponds to a node in the graph. So now if I make a let's say adjacency lists itself to make a particular graph. So one can be used as a particular index itself, but now this string cannot be used as an index since it cannot be directly mapped. So again, I need to use a hash map in place of the string so as to get a particular map to this string where it can be used. But numbers can be directly indexed in the adjacency list so as to get which of the nodes are connected.
Oh, wait a minute. If I have like a, if I have a node that's like 1, and then it has like 2, 3, 4, 5, 6, for example, and then I
Yeah.
want to like go find 4. Why is it faster to find 4 than it would be to find, XYZ at mail.com? Why would looking up the 4 entry in my node map or whatever I'm using be faster?
No, here I meant that this xyz@mail.com would be a number itself and not a
Yeah, I understand
particular
you're
string.
suggesting that we replace all the email addresses with numbers. I'm trying to figure out why you think that's a good idea.
Okay. Yeah. Okay. So if this would be a key, and then we would be having, okay, let's say number itself as the values. So now, okay, so in let's say C++, this can be done using a vector of vectors itself, but this cannot be done directly using a vector of vectors, or else we will be using a vector of strings, and then we would be iterating through the values itself. So
Sure,
if we are
but
using a vector of strings,
let's say that you are building the graph, and I
yeah,
have converted in my representation things to like your number representation, right?
yeah,
And I get a new email address, wilbur@hotmail.com. How do I know if wilbur@hotmail.com is in this your vector of vectors that just has a bunch of numbers in it?
yeah. So before, yeah, so before
I
building the
mean, what you
graph
would have to
itself,
do is you would have to have
yeah,
another secondary map that was like key
yeah, which would map,
wilbur@hotmail.com value 7, at which point
yeah, yeah,
you've introduced another layer of
another,
indirection, and you're using up
yeah,
more space than if you just had a single dictionary. So let's get rid of this. I'm going to veto this idea about using number indirection, and let's just use the actual email addresses, please. This is not a good idea.
all right. Yeah, so, okay, so now what we can do is using each of the, yeah, using each of the email IDs as the node, and then the value would be each of the corresponding email IDs in the list, and then yeah, this is how we will construct the graph. So since it would be a bidirectional edge, so we would be adding both the, yeah, so for the first list we will getting this as the structure of the graph, and after this again we need to go through each of the individual uh, list and then construct the graph as it is. And
Okay.
after we have yeah,
So let's say
and
you have
after,
your graph
yeah,
constructed. How do you actually produce the output from a constructed graph?
yeah, now I will be needing a another dictionary which would be visited. This will mean that I have visited a particular string or not. So if I already visited a particular string, so it means that it would be common to some previous string which we have already computed. So I don't have to particularly include the current name in my final answer.
Okay, what type of thing is this visited? Is it what is it?
Yeah, it would be a dictionary again.
Okay, we've got
So
it
it would be
visited.
having, yeah. So if
Actually, why does it
correct,
need to be a dictionary? Why couldn't it just be a set?
Yeah, we can use a set in place of a dictionary as well.
Okay,
But
so go ahead.
yeah, okay. Yeah, so if a string is already present in my set, so this means that it is already being visited. So I don't have to again do a traversal here. And this means that my current string John would be already being computed previously in my previous iterations.
Okay, I think you jumped ahead a couple. It's like the visited thing is fine, but what are you actually going to do to traverse the graph?
Yeah. So now to traverse the graph, we will now start iterating through the account list. So John would be the, so for
Wait a
John, we
minute,
would be
we built this graph? Why are you now going
yeah,
back to the account list? Why don't we focus on the graph?
yeah. But if I again go back, if I don't go back to account list, how would I be knowing which name it corresponds to?
Yeah, I mean, you obviously need to know what name the nodes correspond to. That's a good point.
Yeah,
Is there a way to keep track of that? Well, let's put it this way. If you were going to go back to your account list and each time figure out which email map to which name, how computationally expensive you think that could be?
yeah. So I think again we would be needing a yeah. So the email has to be again mapped to a name when after we construct the individual graph itself, so as to know which this email corresponds to which name in my input list, so that I don't go back to the account list again for further iterations.
Sure, how can you keep track of that information?
Hmm. Uh, I can use a dictionary here, I guess, so as to map in each of the individual email IDs to the name, and so as to know, uh, yeah, so as to know after uh, the traversal is being done, I'll get to know that all this email ID corresponds to, or even one single email ID corresponds to which name, and then
Okay,
so
great. So let's say that let's like maybe write out that variable at least so that we know what it's called. So we're at least starting to build a little bit of code here.
yeah. So should I jump to code? And
Well,
then we
I would
can see
just
how.
write out that dictionary like you wrote the visited, write out
Yeah,
what do
okay.
you want to call your yeah, keep the visited, that's fine.
Yeah.
That can stay, but then also below it, write out your other dictionary you're going to use to keep track of the relationship between keys and values.
Yeah, so I think it will be email to name. So this is how we will be knowing that which email corresponds to which name.
Okay,
So here, yeah, so here John Smith will
I
be
got it. John
corresponding to,
Smith corresponds to John. Makes sense.
yeah,
How okay, again, we've got this graph, you've got this visit and this email to name stuff. How are you actually going to go about going over the graph and finding the information you need?
yeah. So now the only thing which remains is we need to traverse the graph itself, which we already computed. And how do we decide if yeah, how do we decide which is the first node in the graph, or the point at which I can start iterating or traversing the graph? So this is why I would be needing another space where I would be storing all the unique email IDs, such that I can start iterating through or traversing the graph using the unique email IDs.
Okay, how are we going to store the graph? What was the data structure we settled upon?
Yeah, so So the graph would be itself. Yeah, so this is the structure of the graph, which we can see. It will be email IDs first, and then the list of.
Yeah, but what data structure is that? I just want to be explicit about it. It's not a trick question.
Yeah, so this is a adjacency list representation in C++. We can do this using we can do this using a vector of strings. Otherwise, in Python, we can use this as a dictionary where the key is the first value, and the value would be the list of nodes having common edge between this parent node and all these child nodes.
Oh, okay, so I like the idea of a dictionary.
Yeah.
So given that it's a dictionary of these nodes, that can you like iterate across that dictionary, for example? Like how are you going to pick out nodes to start with?
Yeah, so now let's say this denote so let's say I gave this dictionary itself the name graph, and now to go through each of the key values in the graph, I'll just iterate through uh, the graph itself, and yeah, so if I is already visited, so if it is already visited, it would be present in my visited list. Otherwise, if it is not in my visited list, so this means that I can traverse the given node.
Mhm.
So here I will call my traverse function, and I will pass. No, I cannot call traverse. Okay, I can call traverse directly, and I will pass the given key of the graph, which is I. So instead of taking I can take this as node. So this is my starting point of the traversal. And now I can just traverse the node. And in the traverse node, we will just go through each of the uh, adjacent node of the particular uh, current node. And we would be filling all these nodes in the visited set. So this means that once I am done with the first traversal, when I come at the second node in the graph, since it would be already present in my visited list, I won't traverse it again.
Okay. So we're iterating through all the nodes, we're traversing each individual node. I mean, yeah, please start filling in some part of this with more detail.
All right, so I think I can start writing the whole code, and then we can see how this will work. Shall I go ahead?
Yeah, please start filling in some of the details.
Okay. So let's say the function name is account list, where I need to return the list of accounts after I'm done processing all the accounts. Now to construct the graph, let's say I've taken a graph dictionary and then iterating through each of the items in the accounts list. First, I need to get the email to name mapping. So this is why I will have email to name dictionary. And now for each of the items in my account list, I again have to so now I will be constructing the graph, and again I would map each of the email IDs to the name. So how do I do this?
So is this accounts? Is that the top level input?
Yeah. So this is the
Okay.
same accounts which we have input. So the first node would be coming from the range 0 to length of items, but from the first index, since the 0th index is the name itself. So yes, so 0th index is the name, which I am not including in my graph. So this is why it is just iterating through the given sliced list. And then first I would map that particular node one to my name. So this is why email to name would be the key would be the node one, and then the value would be, let's say if this already existed, then if this already existed, then we don't just copy the previous value. If it does not exist, then we take the current item. So it is items of 0. And now I have the first node in the graph, and no, this to get node 1, I would be needing the current items or instead of doing the slicing, I can just iterate from the first index of current item and then assign item of I. So this would be my first node, and yeah, I think this will be fine. And now to go to the second node, I will go from I plus 1 so that there won't be any repeating cases or duplicates in my dictionary. And now in my graph list, I'll check if I in graph or if node 1 exists in the graph, then I'll just append my second node or the node 2. But I have not defined node 2. So to define node 2, it would be items of J. Else I would be assigning a single valued list which will have node 2 in it. And the same would be done for node 2, since this would be a bidirectional edge. So this is why the same thing has to be done for node 2 as well. So if node 2 exists in my graph, we just need to append node 1. And if node 2 does not exist in the graph, you make a new key in the graph and the value would be node 1. So this is how we finally have the graph constructed. And
okay,
yeah,
and what
we
do you
have
think the runtime of this part here is? From like line 59 to 73?
Yeah, so since in each of the individual list in my account, I am iterating twice. So this is why Yeah, so if let's say the length of the individual, if the length
Let's
of
say you
the
ran this on
individual,
all the segments, all of the, John, Mary, all the segments in your accounts. And then the total length of, if you merged all the lists together, was n, like all the individual, the total number of strings and all the sublists put together, that's n. What do you think the runtime of this graph building solution here is?
then I think it would be order of n square, since for each of the nodes, we are again iterating through the entire sublist. And yeah, so for John, I'm iterating through the entire sublist. For Johnny underscore New York, I would be again iterating through the entire sublist. So it would be order of n square.
Okay, and I
If I'm
guess
not,
what you're trying to do, if I'm understanding this correctly, is you're trying to, for example, you want to have a direct connection from John Smith to every single other subsequent node in that sublist.
yeah.
Why do you think you need that?
Yeah, so if let's say we had some more email IDs inside this list, so in that case, yeah, so in that case, how do I map this Johnny Smith to that particular email ID?
So yeah,
That
let's
can,
say we had, let's say you had several other email addresses in there. And I don't know, I'll just add one, abc@mail.com. Now, how would you connect is there a way to connect John Smith to ABC without having to
yeah,
connect John Smith to every single email address in the list directly?
yeah. So we can add a node between John Smith and then John New York, and then a node between John New York and ABC.
Okay.
So in that way, we will just traversing once.
Okay. Can you fix your code to be linear instead of quadratic then?
Yeah. So we will be getting rid of the another for loop. So instead to get my node 2, I would be taking just the I+1 node. And yeah, so this is the only difference I need to do here. That is take the current node and the adjacent node in the list, and then just construct the graph as it is we did earlier.
Okay. And I think that is a good stopping point. We've actually been going for about 45 minutes, and usually these, you have a sense of the real interview, you generally only have about 40 minutes to work on a problem like this. And this would be the point of the interview. If this was a real interview, that I'd give you like 5 minutes at the end to ask me questions about the company. But I think we're ready to move on to the next stage of our mock interview process. Daniel, could you remind me how that usually works? The next step here is?
Thank you, Elliot. So we'll go to the next step. Abhishek, how do you think you did in the interview?
Yeah, I became pretty nervous about the question. So first I saw that we can do a hashman kind of mapping, but then yeah, then I came across the graph approach, but then I could have implemented this more faster if I had explained the approach in a short span of time. So I think that is one of the mistake which I did. And yeah, I think I started with a brute force approach. That part, uh, I think I did good in that part. And then to optimize my brute force, I think I took too much of time. So that is
Okay,
one of the mistakes I did.
okay. Thanks, Abhishek. So Elliot, what suggestions do you have to?
Yeah,
What did you
I'll
have to give
say
him?
I don't think that with some types of problems, it is the case that you can start with a brute force solution and then work that down to some other type of more optimal solution. I think there are other types of problems where if you're aware of the algorithms and data structures that are available, and you just sort of think about what algorithm or data structure could I use to solve this problem, then the problem goes from being very difficult to being much easier. And I think this is a case where when essentially what it's asking you, you've already even used this term at once, it's asking you to get the collected components, it's giving items that have relationships between each other. That's when, the idea of a graph should jump out at you, and you should be looking at something like a breadth first search or a union find. And that's another comment I'll have, is like, even with all the time we spent on discussion, I still don't know what graph traversal algorithm you're using or how it would actually solve the problem. We got as far as you're going to traverse the graph. You're going to basically have a visited set, which yes, you would need, and you're going to do some kind of graph traversal. And I don't even know if that's going to be a BFS or a DFS or what you're going to do, or if that's going to, approach in solving the problem in any way. So I think that even after you identified a graph, you needed to actually describe the algorithm. And I spent a lot of time trying to get you to describe the algorithm you would use, and I never got it. And I think part of the reason was we kept getting pulled off into all these sort of weird side things that made me think that maybe you're missing some basic understanding of the underlying data structures, like hash maps versus vectors. And for example, this idea that we were going to get rid of all of the strings and we were going to replace them with numbers, and that would somehow be more efficient. Or the idea that we were going to use a vector of lists instead of a dictionary. And then of course, finding items in the vector is going to be a linear time each time, as opposed to constant with a dictionary or a set. There were a lot of things where I was wondering, maybe you need to go back and review like dictionaries, sets, array list versus linked list, that kind of thing, so you feel really comfortable with those data structures, because it didn't seem like you were making the right types of choices, and that really got us bogged down and wasted a lot of time, and also would make me wonder, like, does this person understand runtime complexity? Because you kept just suggesting things that were like, n squared. Let me see what else I've got here. I felt like you could have taken hints better, definitely, in that when my tone of voice is like, why are you doing that? That's like, maybe I shouldn't be doing that. And there was a couple of things where I was like, why are you doing that? And sort of taking the hint, you kept trying to go after that. I think at one point I literally had to say, okay, no, we're not doing that. I'm vetoing it, moving on. Like it should never get to that point. You should follow hints from the interviewer. And yeah, let me see, what else have I got in here? And yeah, and I think the most important part is to go over those fundamentals. And then, just in terms of graphs specifically, I feel like this is a problem where if you're familiar with the core graph traversal algorithms and have used them, then it should pop out to you right away as a graph problem. I guess that's my feedback for now.
Okay, thanks, Elliot. Thanks a lot for the nice feedback. Abhishek, I think it will be really helpful for you. And others, audience, do you have any suggestions or anything regarding the interviewer or candidate? So it's time for the audience. Does anyone have? Okay, I think I'll stop the recording.